Hello, I'm JW. Today we're going to have a look at a demonstration which shows the differences between AC and DC and why you don't normally use DC, and if you are going to use it you need to get special switches and other equipment, because if you use things designed for AC on DC, bad things can happen. Now a quick look at the setup we've got here. The load we're going to be using is this electric heater, and we've seen this in some other videos before. It's a fairly old one. Now this heater, like most resistive loads, will work perfectly well on DC. It still heats up and the light in the bottom will still come on as well. So in that regard, not a problem. So that's going to be the load we're using, and I've got the power coming in here on this block here. Again, we've seen this before. If you want to buy one, links are in the description to this video. Multimeter just to show the voltage. And then on this board here we've got a terminal block here, which is where the power's coming in here, the AC power in this case, and then the earth connection. These are just connecting to the meter there so we can see the voltage. And then we've got a wire here which comes out, actually goes down to the floor there, so there's the thing where the heater is actually plugged in, the lead just comes back up and goes into the heater. And in terms of switching this on and off, because we want to actually see what's going on inside the switch, then we actually have this thing here, which is basically a piece of plastic, some kind of clip there, and it's got two contacts, one at the top and the bottom, and then we can close the switch there to turn it on, and of course release to open the circuit. So perfectly normal there. And voltage wise we can actually adjust using the variac. That's down on the floor here as well, so I'll adjust that to various different voltages. Now that's for AC of course, and to convert AC into DC you need something similar to this here. So what we've got here are the wires here are the AC input, so the blue and brown there, and this goes into the bottom here. This is a bridge rectifier module. Essentially it's four diodes arranged in a rectification arrangement. There was a little diagram on the side, and on the top here we've got two additional wires which are basically the DC output, the red and black in this case. So it's going to be a positive and negative, and basically what comes out of this is going to be pulses of DC. This on the back here is just a heat sink to dissipate some of the heat there, and because we don't really want pulses, we want it to be smoothed out somewhat, then we have these things here which are capacitors, which basically store the charge and therefore smooth out the pulses into something so it's reasonably consistent and obviously is the DC that we wanted. These are a bit manky because they're actually out of some old bit of equipment, but they still work well enough for the purposes of this. They're not particularly good condition, so they've been leaking on the top and pretty poor, but they are being thrown out and they're going to do just fine for this. And then the other thing here, this is a resistor, it's 100k, see on the back there, and that's basically across the capacitors so that when the power's turned off, this will just bleed out any remaining charge in the capacitors, because without that, if we turned off the power, then these could still have a significant amount of power stored there, and obviously that could be somewhat dangerous. Now we'll try this with AC to start with. So basically what we're going to look for here is any kind of spark we'll get on the switch contacts as they open and close. You can see the voltage on the meter in the back there, basically zero at the moment. And I'll put the heater here because this actually has a red light in the bottom. So when the heater's on you can actually see that there's a red light coming out the bottom there. So just a bit of indication there. So it's powered on there, we'll turn it up to a reasonable kind of voltage. This is a 240 volt heater, so let's just go up to say 120 to start with. So it's roughly half of its normal voltage. And we can just use the switch here. So if we turn on there, you can see the red light has come on, or orange in the bottom of the heater there. And you can see as we open and close the switch, there's really very little in the way of a spark there. Possibly hear a little click as it opens and closes. So turn up the voltage to the normal operating level, which in this case is about 240. So let's go to about 240 there. And again, if we look at the switch contacts, as we see a very tiny spark there, and see the heater is obviously turning on there with more sort of yellowy glow there as it's at its normal voltage. So nothing particularly spectacular there. Now this is pretty much the same setup. The only change here is now we're using DC from that rectifier and the capacitor assembly, and of course we've changed the meter to display volts in DC because of course that's what we're using. So there's the heater on. And if you have a look at the spark there, on the contacts. A bit difficult to see, but there is certainly more of it there. Now let's try it again at these, what we would call the normal mains voltage. So in this case, got it up to about 240 there. And again, have a look at the switch contact. So switching on, no problem there. As you can see, the heater light has come on. And then look what happens when we actually open the switch contact. As you can see, it arced there for a significant amount of time before the actual thing switched off. Bearing in mind, when it was arcing, the heater was still powered. So let's try that again. Now bearing in mind that if we try and open it as quickly as possible, we still get the same problem. And if it's opened slowly, of course, as you can see, it's now actually melting and it's in a fairly poor state. Here's a closer view of the switch there. Here's a look at the switch here. Basically it's just made out of a couple of screws or bolts here, one at the bottom, one at the top. You can see the top is still fine, just got the shiny metal there, but inside, see, it's completely burned away and destroyed. And bearing in mind that the arc here was consistent across these two, even with quite a large gap between, I'll say this thing can open to a considerable number of millimetres there. Now normal switches, designed for AC use at least, only have about a 3mm contact gap. So that's pretty small. It's actually less than the diameter of this fiberglass rod here. So if it's going to do this kind of damage to something with a fairly wide contact opening, what kind of damage could it cause to a switch or something if you, say, used a normal AC switch on a DC circuit? And this is the sort of thing that would happen inside. So that's basically why we don't use AC switches on DC, because this is what's going to happen. And as you saw in the arc there, whilst the arc is going, the power is still applied to whatever it is that you're using. It doesn't actually disconnect things until the arc extinguishes. So that's the difference between AC and DC. And the reason you get that large arc on DC and not AC at the same voltage is because DC is, as the name suggests, direct current. The current and the voltage are applied continuously for the whole time. But on AC, or alternating current, then it actually crosses through the 0 point 100 times a second, or 120 if you're in a 60 Hertz country. So basically 100 times a second is actually going to 0 volts and effectively switching off. And then of course when it comes back up again, it's effectively trying to recreate that arc over a fairly large gap. So not normally a problem AC, though you do get a very small spark, but of course on DC, to actually break that arc you need a surprisingly large gap, and hence why switches designed for DC normally have a much bigger gap, and also normally have a very fast opening mechanism to get the gap as large as possible, as quickly as possible. So that's it for this time. Next time we may have a look at putting some actual switches in there, because this is just a demonstration. But until then, thanks for watching.